Hi everyone, today I'm going to talk about my research, high-frequency performance monitoring via architectural event measurement. Obtaining detailed software execution information via hardware performance counter is a powerful analysis technique. The performance counter provides an effective method to monitor the program behavior, which can be used in various applications. There are a lot of open source tools that have been developed to provide a high-level API to control and collect the performance counter data. However, there are some drawbacks for these available tools, such as the low timer granularity, high performance overhead. Some tools require the source code implementation, and some tools require the user to patch the kernel. To address this limitation, we introduced K-LEB, a performance counter profiling tool that utilizes the kernel space collection system to produce a precise, non-intrusive, low overhead, and high periodicity performance counter data. The figure shows architecture of K-LEB. The controller process is used as an interface to allow the user to control the kernel module from the user space by passing the parameter to the kernel module to set up, start, and stop collecting the data. The kernel module is used to access the PMU to set up and collect the performance counter data, while also tracking the process being monitored using the scheduler in the kernel. PMU is a special hardware register that resides in the processor, which is used to monitor the hardware event. The monitor process is the process that is being monitored by the kernel module. By moving the collection mechanism to the kernel, it allows the use of high-resolution timer on the kernel level, which provide a finer timer granularity than the user-level timer. Our tool can support up to 100 microseconds for the sampling rate, which is 100 times faster than the current available tools. K-LEB uses a scheduler in the kernel to keep track of the monitor process. This allows K-LEB to be non-intrusive to program being monitored, as it does not require the source code modification or having to interrupt the program workflow to be monitored. K-LEB also mitigates the overhead effectively by collecting and keeping the performance counter data in the kernel space. This method reduces the expensive overhead from the extra system call the auto profiling tool have to make in order to collect the performance counter data. From our case study, K-LEB showed to reduce the monitoring overhead by at least 58.8%. With all these features, I believe K-LEB would be suitable to be used as an online or live analysis tool to monitor the program that might require a high frequency sampling rate with low overhead and without interrupting the workflow.